Okay, guys, today I want to talk about how to determine a correlation coefficient and just how to identify it from a graph. Now, we're actually going to go ahead and calculate some correlation coefficients, but that's for another day. Today, we just want to be able to look at the graph and say, hey, which one is which? You know, which one has a positive correlation coefficient, which one has a negative correlation, which one is strong, which one is weak. So let's start with this. Any correlation coefficient, okay, has to fall in here. Okay, it's got to be a number between -1 and +1. Okay, zero is in the middle here. Okay, if you want to, you could think about these almost as percents, right? This is a -100% and a +100%. Okay, and the tricky part is that any correlation coefficient will essentially, whether it's positive or it's negative, it can be very, very strong. Okay, so I'm going to show you an example of a positive correlation of 100% or 1, and a negative correlation of 100% or -1. Okay, so you're going to see these numbers as -1 and +1. But again, if we want to think of them as kind of like being perfect positive and perfect negative, that's fine. So if you're given a piece of paper like this, right, and so let's say I was given this, right, and I'm going to have a slope of -1/2, down 1, over 2, down 1, over 2, down 1, over 2, down 1, over 2. Okay, so this is linear slope, right? This is a straight line, right? If I connect the dots, I'm going to get a slope, right? So if we said, is there a pattern there? Yeah, there's very clearly a pattern there. So essentially what you'd want to do is you'd want to go ahead and draw a line straight through these, right? If the line hits every single point, this is a correlation coefficient of -100%, okay? So you're saying, why isn't 100%? The line's going down, okay? As your x values go up here, your y values are going down. This is a -100%, or as we normally put it, a correlation coefficient of -1, okay? Now, how does this start to weaken a little bit? This starts to weaken when you have other points, okay? Now, I also give you this skill called an outlier, okay? This comes pretty naturally, people. This is the outlying point, right? This is the weirdo point. This is the point that doesn't fit, right? Okay. As you add this, now there's still a really strong correlation here, right? But it's no longer -1. You have an outlier. And as I add these other points in here, all of a sudden the line that I'm drawing through here isn't quite the same. It's not going to follow those points perfectly. It's probably going to go something, I don't know, maybe a little more like that, right, where I have kind of half my points on either side of the line, right? Now, again, it's still a negative correlation, but it's not the -1, right? So this might be a correlation, I don't know, probably somewhere in here. You know, this might be a correlation of -0.8, right? So again, is it a perfect correlation? No, but it's still pretty strong data. Like pretty strong. This data pretty strongly suggests as whatever x goes up, y is going down. Okay. So let's clear all this. Forgot that I can't erase this. Okay. So let's take a look at what a positive. So again, a correlation of +1. Okay, would be something like this. This is a perfect correlation, right? If I draw the line through these data points, it's going to fit exactly, right? And there could be gaps. I mean, let me leave a little gap here. What if I said this? Well, you can still very clearly draw a line through all these points, yes? So if you said, hey, what's the correlation coefficient, which we usually call R, by the way, I'm sorry, R, this R is equal to 1. This is perfect, okay? This is a 100% correlation. This is a perfect correlation, right? There are no data points, right? How do we weaken that? Let's throw in a couple out here, right? We throw in a couple out here, and all of a sudden, maybe not. right? This might be a 90% correlation. This might be R of 0.9, okay? So that's what you're looking for. You're looking for is, hey, number one, when I draw that line to best fit, when I draw that line through the points, is it going up or is it going down? If it's going up, positive. If it's going down, negative, okay? Then the next thing you want to look at is, hey, how tightly clustered around those points are there, okay? And there is one more that we do need to look at, and that is, what is a correlation of 0? Well, a correlation of 0 has no positive correlation or no negative correlation. In fact, it's probably the worst thing you can have for your data. It means your data is pretty much totally random, right? Now, if I said something like this, okay, pretty weak correlation, right? So this is clear, it's going down, right? As X goes up, Y is going down, right? So this is a weak negative correlation, right? But what happens as I kind of do this? Now there really is no correlation, right? Like if I want to split these in half, it could be what? It could be a line going down, maybe. It could be maybe a line going up. It might be a line going straight across, right? Like there's really a lot of different lines I can draw to split this in half. What that means is that there is no correlation, that there is nothing that definitively says as X goes up, Y goes down. This data doesn't tell us anything about correlation. What this would say is that there is no relation, which, by the way, when you're taking data, might be something that's very important, right? Like if you were looking at the relation between eating sugary cereals and tooth decay, right? You'd expect that the more sugary cereals you eat, the more tooth decay there is, right? But what if you wanted to say, hey, what's the relationship between eating, I don't know, white bread and tooth decay, right? Well, what if you got this data? It might show you that there's not much of a relation there. Maybe there is, I don't know. But I'm just saying that there are things where if you were trying to prove something, you might be trying to prove there is no relation. So keep that in mind. We'll talk about some specific examples. But for today, all you're looking at is, hey, does the line go up? Positive. Does the line go down? Negative. Are the points clustered closely around the line? That will be closer to +1 or closer to -1, okay? So just go over a few examples. Match the correlation coefficient. So they're both going up. This is a much nicer cluster than this. This will have the number closer to +1. Okay, oh, we're in the challenge zone. Oh boy. Again, we got 4 now. Okay. So again, I got a positive and a negative and a positive and negative. So the ones that are going up are clearly these two, right? These are two that are going up. I have positive, positive, negative, negative. This is a good correlation. This is a weak correlation. Down here, I would say that this is the stronger correlation. And this is the weaker correlation. Okay, let's go ahead and submit and see what they said. Fantastic, okay. Again, like I said, which one of these has a 0 correlation? If you look at these, which has the worst data, I'm going to go ahead and say that this one does, right? These are kind of scattered all over here. Initially, I want to say this one, but they do kind of generally trend up, right? So I would definitely say that is the weaker correlation. This one's going down, and this one is going up. Okay, very tight correlation, very close to 1. Okay, so give those a try. Let me know if you guys have questions, and we will take it from there. Good luck, guys.